Okay, we're looking at question 11 on 5.4 homework. This one is the more challenging one. What I want to start out with is it's telling us that these triangles are congruent. So I'm just going to start out by drawing some triangles. I'll just copy and paste it so that we kind of see quite clearly that they're congruent. And I'll make sure I get this order straight. N goes with C. So these correspond. These are the same. E goes with A. So I'll make this E here, which means I need to make this right here A. And then finally W goes with R. So W goes here and R goes here. Give these guys the triple arc. Okay, this is going to help me so that I can use this to clearly see what's congruent to what. So EN is 11, that's stated here. I know AR is 2x minus 4y. NW is x plus y. CA right here is 4x plus y. And then EW is 10. Cool. It says find the values of x and y. So what you'll notice is a lot of these have x's and y's in them, the expressions of these side lengths. So you're probably going to have a system of equations. Systems of equations you'll see quite often in all your math classes. So if you don't feel comfortable with them now, come into tutoring and get some help. Make sure you feel comfortable with them soon because you're going to continue to see them. And they're not too difficult, you just really need practice. So I know that NE is congruent to CA because those are corresponding sides. NE goes to CA. They're the first two letters for both of those triangles. That's why order is so important. So I know 11 is equal to 4x plus y. Okay. Now I also know that EW is congruent to AR, as you can see in the congruent statement. EW, last two letters, goes with AR, last two letters. Alright, so we know that 10 is equal to 2x minus 4y. Okay. And we don't have CR, so we're not going to compare that to NW. We're not going to write an equation based on that. So this is a system of equations. There's an x value, a y value, and there's two equations with both those variables in both of them. So there's actually three ways you can solve this. You can graph them if you feel comfortable graphing them and see where they intersect. This is a minus. Check it out. If you graph it, you can see what the solution is. The solution is going to be right here, right where they intersect. Looks like 3, -1. But I want you guys to be able to solve this by using substitution or elimination. So substitution, if I were to go the substitution route, I'd start with the first equation since y is by itself. Okay, when the coefficient is 1 on a variable, that's a good indicator. You can use it for substitution. For example, I can subtract 4x from both sides of this equation, in which case I would get 11 minus 4x is equal to y. And then I can substitute the value of y, which is 11 minus 4x, where I see y here. Okay. This is the first route, substitution. Because when I substitute it, so notice, where it says y, I'm going to replace it with 11 minus 4x. It's very important that I use parentheses here because the distributive property has to be applied. Because this, all of this right here, is y, so I need to multiply both those terms by y. So let's see what happens. We get 10 is equal to 2x minus 4 times 11 is 44, and then negative 4 times negative 4x is positive 16x. I'm going to combine these like terms to get 18x. Okay, and then add 44 to both sides. I believe this is actually divisible if I divide both sides by is it 3? Yeah, 24. Okay, yeah. Yeah, good. Huh. X equals 3. Good. Now that I have the value of x, I can plug this in into either equation, either of these original equations, either right here or right here, and I can find the value of y. So I'll do it with the second equation, 2 times 3 minus 4y. This is me plugging in 3 for x. Then I get 6 minus 4y equals 10. If I subtract 6 from both sides, I would get 4 is equal to negative 4y. Divide both sides by negative 4, and I get y equals negative 1. So I would get my x and my y here. I'm going to now do the elimination route, and you can decide which one you prefer. Of course, there's different situations call for different paths to solution. Sometimes substitution is better, sometimes elimination is better. Some might think that elimination is better here because you'll notice if I multiply this equation here by 2 or negative 2, I'll have the coefficient on x here match up with this one, and then I can eliminate. So for example, I'm going to multiply this by 2, the whole equation. I'm going to rewrite the first equation here, and then below that I'm going to write this equation but multiplied by 2. So now I'm able to eliminate. You can either add or subtract one equation from the other. In this case, I want to subtract because 4x minus 4x equals 0. And that's the goal here, is to get rid of either the x or the y. In this case, we could get rid of the x. 11 minus 20 is negative 9. 4x minus 4x is 0, so those cancel. And then y minus negative 8y is y plus 8y, which is 9y. Right? I'm just going to write this on the side. Y minus negative 8y is y plus 8y, which equals 9y. Okay, just a little side note there. Okay, in this case, I can tell, divide by 9, and I get y equals negative 1. And since I have the value of y, now I can plug it into either of these equations, this one or this one. So I think I'm going to do it in the first one. Since y doesn't have to be multiplied here, it'll just be the negative 1. So 4x plus negative 1, which is the same as minus 1. If I add 1 to both sides, I get 4x equals 12. Divide both sides by 4, and I get x equals 3. Notice I get the same solutions. Okay, negative y and positive 3. This allows me to find CR, because CR is congruent to NW, and NW is equal to x plus y, but now I know my x and I know my y. So my x value is, so let me just write this out. Let me write this full statement. CR, alright, the measure of CR is equal to the measure of NW, which is equal to x plus y Since x equals 3, y equals -1, I get 2. The length of NW is 2. Then it says classify the triangle NEW by its angles. Okay, so the thing here is we don't have the angle measures, but we know how to classify a triangle by its angles, but using its sides. Okay, using its sides. So it's either acute, obtuse, or right. So let's take the longest side here, and I'm going to replace x plus y with 2. Side note, this is clearly not to scale, but I drew the triangle without knowing what the scaling's like. So, remember, if you're trying to classify it as acute, obtuse, or right, by using the sides you need to use c squared is less than, greater than, or equal to a squared plus b squared. Okay. That was on our first exit ticket and our first test, 5.1. This is all 5.1 here, okay. So c squared, that's our longest side, which is 11. 11 squared, is it greater than, less than, or equal to? And we just have to use the two other sides. The order does not matter, like so. Get rid of all this. Give me some space. Okay. 11 squared is 121. 121, is it greater than, less than, or equal to 4 plus 100? (121) is greater than 104. So we know it's obtuse. It's an obtuse triangle. Okay, important that we go back to what we know from earlier chapters.